In this lesson, we shall solve questions on analytical geometry, that is also called coordinate geometry, and we shall continue to look at other forms of geometry like Euclidean geometry, etc., etc. Right, in the diagram, S with coordinates 0 and minus 16, L and Q with coordinates 4 and minus 8 are the vertices of triangle SLQ, and LQ right, having LQ perpendicular to SQ. Right, here is L, here is Q, and this LQ is perpendicular to exactly SQ. Okay, right, SL and SQ are produced 2 points R and M. Right, SL and SQ are produced 2 points R and M respectively, such that RM is parallel to LQ. Right, so RM is parallel to LQ, and that is very, very visible there. Next, SM produced, right, so you have SM produced, cuts the x-axis at N with coordinates 8 and 0, QM and M equals MN. Right, so you're able to see that exactly QM is equal to MN. T and P are the intercepts of RM and LQ, respectively. T and P, right, so you have T, right, that is here, and P are the y-intercepts of RM and L and LQ, respectively. You can see the T and P there. Calculate the coordinates of M. Right, what is the formula? Anyone? How to find the coordinates of M, the midpoint? What is the formula for the midpoint? Who knows the formula for the midpoint? So we shall look first at question 3.1 in the midpoint formula, because you want to find the coordinates of M, and M is here. So we shall say x1, y1, and then here we shall say x2, y2. x1 plus x2 out of 2, y1 plus y2 out of 2. What is x1? It is 4, x2 is 8 out of 2. y1 is minus 8, and y2 is 0 out of 2. What is 4 plus 8? 12. Divide by 2. It's exactly a 6. Minus 4 plus 0. Minus 8 plus 0, which is minus 8 divided by 2. It's a minus 4. It's a minus 4. So this here becomes the answer. So what are the coordinates of M? The coordinates of M are exactly 6 together with minus 4. Right, so, and obviously this formula here is the formula for finding what we call the midpoint. The midpoint. Right, so it's a finding coordinates of what you call the midpoint. Okay, next point. Next point. Calculate the gradient of NS. The gradient of NS. What is the gradient of NS? Well, the gradient of NS, we actually, now to find the gradient of NS, we use what we call the gradient formula. So that the gradient of NS is the same as what? It is change in y, change in x. y2 minus y1 divided by x2 minus x1. So if you have to look at n, which is here, and s, which is here, right, starting from n to s, x1, y1 at the point n, and x2, y2 at the point s, so that y2 is minus 16 and y1 is 0 divided by x2 is 0 and x1 is 8. Like so. And this is minus 16 over minus 8. And what is the result? It's a 2. And that means the gradient of ns is equal to 2, like this. Gradient of ns is equal to 2, that way. Where's the question? Dando, do you understand what is happening? Right, so in the absence of a question, you understand, Dando?
Yes, sir.
Okay, yeah, that is the gradient formula. The gradient formula, so this formula is for finding what we call the gradient. The gradient. So the gradient of a line can be found by using this formula. What is the formula for the gradient? Is change in y, change in x. Change in y over change in x, and we have exactly that. So we continue to, in other words, this is delta y, delta x. And delta y is y2 minus y1, and delta x is x2 minus x1. This becomes the answer. Okay, now let us continue to do 3.3. 3.3. Right, so in 3.3, you shall show that the equation of line LQ is given by that. Right, so you have LQ. What is the equation of line LQ? Right, to find the equation of the line LQ, you need to find the gradient of the line LQ. How do you find the gradient of LQ? To find the gradient of L2, there are a couple of things that remain very, very key. Right, you must first note that the line LQ has only one point, Q, whose coordinates we know. And to find the equation of a line, we must use the formula y minus y1 equals x into x minus x1. Okay, if we don't want to use this one, you use the formula y equals mx plus c, like so. However, if you look carefully here, we need to find the equation of the line LQ, you would need the coordinates of both points L and Q, but only the coordinates of Q are known. So what do? We then decide to determine the gradient of a perpendicular line to the line LQ, and therefore we find the gradient of the line. Any other line, we can choose the line SQ. The line SQ. Right, and we already know, for instance, the gradient of the line NS. And the gradient of NS is 2. So that in the end, then we then say the gradient of LQ times the gradient of NS is -1, which means LQ is perpendicular to NS. What is the gradient of LQ? The gradient of NS is 2. So LQ, the gradient of LQ is -1/2. Gradient of LQ is therefore -1/2. Why? Because if two lines are perpendicular to each other, like LQ is perpendicular to NS, and therefore if you multiply the gradient, you get -1. So that now you're able to say this equation can be obtained by using another fact. This line LQ passes through Q with coordinates 4 and -8. Okay, so yeah, x1, y1. Okay, like this. Like this. Okay, so look. Y1 is -8. What is the gradient? The gradient of the line LQ, whose equation we want, is -1/2, which is x minus x1 is a 4. y plus 8, which is equal to minus 1/2 x plus 2. And therefore, what you are then having here is that in the end, the equation is y is equal to, you can write it here. Right, you can write the equation down here. So the equation of the line is exactly y is equal to minus 1/2 x minus 6, because 2 minus 8 is minus 6. We have been able, therefore, to find the equation of the, in particular, we're able to show that the equation of the line LQ is minus, because the examiner gave us the answer. They say the equation is y equals minus 1/2 x minus 6. So y equals minus 1/2 x minus 6. And that is what we've shown. Okay, pay particular attention to this and make sure that you understand this. As we move to the next question. As we move to the next question. Right, in the next question, we analyze that we want to determine the equation of a circle having center O, the origin. Right, the origin has the coordinates 0 and 0, and also passing through S, this, like this. So what do we have? So now to find the equation of a circle having center the origin, and also passing through S, what is the equation of this circle? Right, to find the equation of that circle, we say x minus a squared, y minus b squared equals r squared, the center. So the equation having the center, the origin. So the center is 0 and 0. The center is 0 and 0, giving us a and b. Y minus that. Okay, so, but also what we have is this particular circle passes through S. So it passes through S with coordinates 0 and minus 16. And this point S gives us X and Y. So that our X is 0 here. And our Y is minus 16. Our Y is minus 16. So that now if you square everything here, we're able to get 256 is the square of the radius. Which means that you have the equation of the circle is going to be obtained from here. So now you have is x minus 0 squared, y minus 0 squared, and this is r squared, and r squared is 256, which is this. X squared plus y squared is 256. So we want the equation of a circle having center at the origin and also passing through S, and that equation is clearly x squared plus y squared is equal to 256, like this. Who has a question? Any question? The next question is we want to determine the coordinate of t. Who can find that? I must give you some things to try. Can you try to find the coordinates of t? Who can find the coordinates of t? This one. Who can find the coordinates of t? Who can find the coordinates of t? Anyone home? Who can find the coordinates of t? Who is able to find the coordinates of t? Right, so let's try that one. And therefore now we attempt to find the coordinates of t. Right, and t is nothing other than what? This point here. And we want to find its coordinates. And the question is, there's something we know. Now to find the coordinates of t in 3.5, okay, so with the gradient of Rm is equal to the gradient of LQ, the gradient of Rm equals the gradient of LQ. And this gradient is minus 1/2, because we already know that the gradient of LQ is minus 1/2. So the gradient, because these lines are parallel to each other. Okay, parallel lines have equal gradients. And this is true because the line RM is parallel to the line LQ. So we're effectively then saying, because RM and LQ are parallel to each other, therefore they have equal gradients, like so. Now, what then are we able to say? We are able to then say, we can then be able to find the equation here. So we use y minus y1. Okay, we want to find the equation of the line RM. But the formula we use is this one, is the slope point form of the equation of a line, which is y minus y1 equals m into x minus x1. This one is called the slope point. It's called the slope point form of the equation of a line. There is another equation of a line that we call the slope intercept form, y equals mx plus c. This one is a special name. It is called the slope intercept. It's called the slope intercept form. It's called the slope intercept form. Okay, so this line here, RM, passes through. It passes through the point, because we're dealing with RM, we want to find the coordinates of T, and T lies on RM. Now, this line RM passes through a point whose coordinates we know, namely the point M. And this point M has the coordinates 6 and minus 4. 6 and minus 4. So here you write through. But okay, you must say this. Okay, yeah, it passes through 6 and minus 4. 6 and minus 4. Right, as it passes through 6 and minus 4, then you have here x1, y1, which is y minus y1, minus 4, right, which equals the slope of the line RM, and the slope or the gradient of the line RM is minus 1/2. X minus x1 X1 is exactly a 6 here. Y plus 4 is minus 1/2 x plus 3. This is exactly minus 1/2 x minus 1. Right, so this is exactly the equation. But to find t, t is a y-intercept. Right, so find a y-intercept. We then say we want to find a y-intercept. How do we find a y-intercept? We let x be 0. So that we have this. So that now in the end, then you have x 0 and y minus 1. So the coordinate of t are 0 together with minus 1. So those are the coordinates of t. Those are the coordinates of t. The next thing is we want to find determine Ls over Rs. We want to find the ratio of Ls to Rs, the ratio of Ls to Rs. And it is very, very interesting that we shall do this question. Right, to find the ratio of Ls to Rs, we continue as follows. So what do we do to find the ratio? Right, we need some lengths. Like, what have we been able to find? We know the coordinates of t. 0, minus 1. We know the coordinates of p. What are the coordinates of p? Right. We found something about LQ. What did we find? We found the equation of LQ. The equation of LQ, we found it to be minus 1/2 x minus 6. Y equals minus 1/2 x minus 6. So that okay, the y is minus 1/2 x minus 6. That is the equation of LQ. And that gives us the coordinates of P, because now when you want to find the coordinates of P, you let x be 0. When x is 0, y is minus 6. When x is 0, y is minus 6. When x is 0, y is minus 6. And then now we are able to use the proportionality theorem. The proportionality theorem is a theorem that we have discussed so many times and we've proved before, but we continue to practice more. The proportionality theorem says if this line is parallel to this, then dB over dA is equal to EB over EC. Like so. Okay, now we look at these and look at these very carefully. But there are a couple of things you can say here. There are a couple of things we can do here. We can do some addition. There's a small game that we play with this, and I want us to play the game. So this is dB over dA, and then you add 1 on the left. You have EB over EC. You add 1 on the right. Okay, if you add these things here, this is dB plus dA over dA. And this is equal to EB plus EC over EC. Okay, let's look at dB. dB plus dA. What is dB plus dA? dB plus dA is AB. So you can also write this ratio as AB over dA. And then now if you have EB plus EC, it is BC over EC. Right, so this is what you have. This is what we have. Okay, we continue. So now to find this ratio, we can just say AB over dA, BC over EC. Okay, now let us continue. Now to find LS, right, we are sure that if you have LS, so we're doing 3.6, LS over RS. Yeah, LS over RS is equal to PS, LS over RS. It's PS over, right, so, because now I want us to look at this very carefully. So if you're having LS over RS, it's PS over TS, like this. And this is true by the proportionality theorem. It is true because LQ is parallel to RM. Okay, let's look at that. LQ is parallel to RM. Okay, that is what we have. So the proportionality theorem therefore says this. But now if you look at these, then we have LS over RS. Then we have PS. What is PS? Right, so we want the distance from P to S. So if you want the distance, you need to subtract these numbers by saying the largest minus the smallest number. Which one is larger between -6 and -16? The largest is -6 minus the smallest number. We proceed to divide by now TS. You take the largest minus the smallest. The largest is -1, the smallest is -16. Like so. And therefore this is LS over RS. 16 minus 6. 16 minus 1. What is 16 minus 6? It's 10 out of 15. And so 10 out of 15 means 5 goes how many times into 10? 5 goes 2 times and goes 3 times. Goes 2 times and goes 3 times. So, I mean, this means that the ratio of LS to RS is 2 out of 3. 2 out of 3. 2 out of 3. 2 out of 3. Okay. Where's the question here? Who is confused? Who is confused? So in other words, here you can write more comprehensively as follows and say you have the proportionality theorem. The proportionality theorem, because you have that Rm is parallel to LP, like this, or M is parallel to LP. Right, so any question you ask, if you have a question, and we look at that together. Look at that together. We proceed now to look at the area. We want to find the area. How do we then find the area? The area of PTMQ, the area of P, T, M, Q. And this here is sort of resembles something we know, and this is a shape that is the opposite sides parallel, just one pair of opposite sides parallel, and this is called the trapezium. And now with the trapezium, you can be able to find the area of a trapezium, 3.7. Area of PTMQ. Which is equal to area of triangle TSM minus area triangle PSQ. Okay, let's look at this. So you can take the area of the triangle TSM. Just write clearly here, means an M. So we take the area of the triangle TSM and we minus the area of triangle PSQ. Area of triangle PTMQ. So what is the area of triangle TSM? Area of triangle TSM. Right. It's actually half the base. The area of triangle TSM is half the base ST. Half the base ST times the perpendicular height H subscript M. H subscript M. Okay, let's look at that. So in other words, if you want to find the area of the triangle TSM, right, you have TSM, you say half the base, and if you take the base ST, and then you multiply it by the perpendicular height through M. And obviously you are dealing with the area of the triangle ST. T, that is TSM. I have it like this, and it has a height there. You're constructing the height that is sitting on the base ST, and the perpendicular height H subscript M minus half the base. The area of triangle PSQ. PSQ is half the base PS, half the base PS multiplied by the perpendicular height HQ. Perpendicular height. So in other words, if you look at the area of the triangle PSQ, you can take the base PS and then we construct the height there. That sits exactly on the base. So if the base is PS, then the height is going to be something like that. There's certain things you know, like we know the coordinates of M. We've already got the coordinates of M, and we got them to be 6 and minus 4. Okay, yeah. Look, then area of PTMQ, and this is a trapezium. PTMQ is a trapezium. And what is the base ST? What is the base ST? Right, so if you look at these and you want to find the base ST, you already know T has the coordinates 0, -1. And now you just want to find the distance. So the distance between -1 and -16 is like 15 units. Yeah, if you subtract this one, -16 minus into -1, you have 15 units. So this is going to be exactly 15 units. So now, which means ST is 15. And then now the height here is the distance from here to there. And the height is sitting at 6 units. It's like what X is here. XM. And therefore this one is going to be exactly 6 units. Yeah, 6. Then you have PS. 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 Which means PS is what? The base, but obviously you already know the coordinates here. And the coordinates here are, we've already got the coordinates of the line that is through LQ is this one. So if you make X 0, Y is -6, giving us Y equal to -6 at the point P. So we continue to allocate that one. So this is 0 -6, like so. Okay, yeah. What is half now? If you say PS, so PS now is going to be the distance here, which is going to be the distance between -6 and -16 is 10. Okay, and then now you're going to be looking at the height, the X. From here, how far do we go horizontally? And horizontally is along the X, because the X-axis is horizontal. So the X and the Y, X is 4, like so. And then we're able to multiply everything, getting 45 minus 20. 45 minus 20 gives us 25 square units. 25 square units. So, and this obviously gives us the area of PTMQ, the area of PTMQ. Right, so we continue to look at more things and to analyze this very, very carefully. So obviously now they asked us to calculate the area of PTMQ. So you can come here and say area of PTMQ is actually equal to 25 square units. 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 Who has a question? Who has a question? A suggestion? Right, so you let us know if you have any of those. And then we continue now to look at the next question. Right, the next question is a circle. In the diagram, P has coordinates -3 and 4 is the center of the circle. Here is P, and it is the center of the circle. V with coordinates K and 1 and W are the endpoints of a diameter. So you need to say V and W. So V and W are the endpoints of a diameter. The circle intersects the y-axis at B. It intersects the y-axis at B and C. BCVW is a cyclic quadrilateral. BCVW is a cyclic quadrilateral. CV is produced, right, to intersect the x-axis at T. CV is produced, and we can see it intersects the x-axis at the point T. OTC equals alpha. Right, so you have OTC, which equals alpha. The radius of the circle is the square root of 10. Okay, radius of the circle is square root of 10. You could also say square root of 10 units. Right, because radius is distance. Calculate the value of K if point V is to the right of point P. Okay, now let's look at this. Calculate the value of K if point V is to the right of point P. Point V is to the right of point P. Clearly show all calculations. Okay, let us look at these, but like very, very carefully. What do we need to know, and what are we supposed to do? What are we supposed to do? What are we supposed to do? So now, to solve this particular question, we proceed as follows. We're looking at 4.1. Want to calculate the value of K if P is to the right. So now let us look at these and look at these very, very carefully and think about what we need to know here. Okay. So we have the equation of the circle. What is the equation of this circle here? The equation of the circle is x minus. So this gives us the coordinates of the center. So it's x minus, open bracket, minus 3, and you square these plus y is y minus 4, and you square this. It is equal to the radius squared, and the radius is the square root of 10. So here, the radius is the square root of 10. So yeah, it is this. So you have this square root of 10. Like this. Which means x plus 3. Y minus 4. 10. This is the equation of a circle, so the equation of the circle. Now, this circle passes through V. It passes through V with coordinates K and 1. And this is X and Y. So which means it is K plus 3. 1 minus 4. Okay, we're plugging in the Y because the Y is 1 here and the X is K. We square this and the result is 10. K plus 3. You square this plus 1 minus 4 is what? Is a minus 3, and if you square that, you get a 9. And this equals 10. This implies that you have K plus 3. K plus 3, which is square, and the result is 10 minus 9, which is a 1. We apply the square root on both sides of the equation, like so. Which means K plus 3 plus or minus 1. Which means K plus 3 is 1. K plus 3 is minus 1, which means K is minus 2. K is minus 4. Okay. So this is what we have. So obviously we analyze this question and look very carefully and think about what must be known and be understood here. So the question we're asking then is, because K is value of K, if V, right, if point V is to the right of point Q, to the right of point Q. So in other words, now K here is what? If it is the right. So if this is to the right, it means that K must be something, a number that is smaller. K is an X value. So it must be smaller than minus 3. So it can't be this one. And therefore, K is only minus 2 in this question. K is only minus 2 in this question. And we proceed to solve more problems. We proceed to solve more problems. And what then we do next is we have shown all the calculations, and we need to solve 4.2 now. The equation of the circle is given as x squared plus 6x plus y squared minus 8y plus 15 equals 0. Calculate the length of BC. Calculate the length of BC. And we continue to determine that and calculate the length of BC. Right, so we continue. We continue. Right, so to calculate the length of BC, what is BC? BC is this one here. So let us do 4.2. Right, in 4.2, want to calculate the length of BC. B is this and C is that. What is the length here? Right, so to find the length of BC, we proceed as follows. We take note of a couple of things, but most importantly, we write the equation x squared plus 6x plus y squared minus 8y plus 15 equals 0. And you want to find the length of BC, and this BC here is on the y-axis. So these 2 points, they're like y-intercept. So you want to find the y-intercept of a circle. How do you find the y-intercept of a circle? Right, so to find the y-intercept, you let x be 0. So x is going to be 0. So you have 0 squared plus 6 times 0. Plus y squared minus 8y plus 15 equals 0. This is y squared minus 8y plus 15 equals 0. And this is y minus 5, y minus 3 equals 0. Y is 5 and y is 3. Okay. So what do we have here? Y is 5, y is 3. Okay, because now we need to order these. Because if you're moving from the origin, right, so it means therefore, what is the distance between 5 and 3?
2.
2, well done. So BC then is equal to 2 units. BC is 2 units. Thanks so much for that answer. Thanks so much for that answer. So now we continue to solve the next one. So now if k is negative 2, calculate the size of alpha. Right, if k is negative 2, calculate the size of alpha. Let us look at this one. So we're looking at 4.3.1, and we're saying if k is negative 2 here, which means that v is minus 2 and 1. Right. Okay. Right, so we continue. Right, so we continue. We continue to solve this one. So what is the value of alpha? This alpha here, this one. So to find the value of this alpha, this angle, there are a couple of things that we need to consider. We need to look at a couple of things, but, well, you already know the coordinates here. And you already know the coordinates. So this alpha is like an angle of inclination. So what are the coordinates here? We saw that this one was 5. And this one was 3. So it's 0, 5, and then 0 and 3 because they are on the y-axis. So here you put 0, 5, 0, and 3. Because these are points on the okay, so that in the end, therefore, now to find the alpha, we then obviously have to consider the k value. There's the coordinates minus 2 and 1. In which case, therefore, we want to find. So you have the line segment CV. V minus 2 and 1. Minus 2 and 1. Okay, I'd already written V, and then I want to write the other point. The other point, whose coordinates we know? We know the point what? The point C. The coordinates 0 and 3. We know the point C with the coordinates 0 and 3. And therefore, we want to find the gradient. So this is x1, y1, and this is x2, y2. So we continue to analyze these, but very, very carefully as follows. And then say the gradient of this line here. The gradient of this line. So the gradient of this line is nothing other than what? Right, the gradient of this line is the m. It's like the gradient of, can call it the gradient of c. Right. Each time you find the gradient or the slope, you use delta y, delta x. Okay, good. But delta y, delta x, it's y2 minus y1 all over x2 minus x1. Okay, now we have the x1, y1, x2, y2 here. So which means that y2 is a 3 minus the y1 is 1 here. x2 is 0. x1 minus 2, like so, giving us 3 minus 1, it's 2 over 2, which is 1. Okay, this gives us that the gradient of TC is 1. Okay, once we get this gradient, we shall be able to we shall be able to find to note that the gradient of TC is the tangent of alpha. And that is the formula. So now we note that always we say the gradient is equal to the tangent. Okay, now if this is the case, what is the gradient? Which means therefore that you can come and say the tangent of alpha is 1. Which means alpha is octane 1. Alpha is octane 1. Which implies that alpha is arctangent of 1. What is arctangent of 1? Right. So that you have, right. So we continue. Okay, this is actually 45 degrees. And obviously here I'm supposed to find the size of this angle alpha, and alpha is 45 degrees. Okay, now please look at these. Think of this carefully. Yeah, think of it carefully. Think of this very, very carefully. Think of this very, very carefully. And we continue. We continue. And now, in the next question, we want to find the size of the angle VWB. The angle VWB. This one. What is the size of this angle VWB? What is the size of that angle there? Right, so we can be able to find the size of that angle. Right, so obvious to find the size of that angle, there are a couple of things we can realize. So we take note of the fact that this angle we already know is 45 degrees. This angle you already know is 45 degrees. If this angle is 45 degrees, this one is 90 degrees. Okay, I remember that in this triangle, then the sum of all the angles must be 100 and 180 degrees. So 90 here, 45 and 45. 45 plus 45 degrees is 90 degrees. Okay, this one here is equal to this angle there. So this guy is also 45 degrees. That angle is also 45 degrees. But this one is exactly the angle, because now they want VWB. VWB. So first things first, we note that TCO, right, can write that. Angle TCO. Right, this angle TCO is 45 degrees. Angle TCO is 45 degrees. Why is it 45 degrees? It is 45 degrees because of the sum of interior angles of triangle. Because of the sum of interior angles of triangle. So that in the end now, this is exactly 45 degrees. This one is 45 degrees. Once it's 45 degrees, then you're able to see that the angle TCO, or you can call it VCO. Therefore, the angle VCO is equal to VWB, angle VWB. Okay? Which is 45 degrees. Why is VCO, this angle, VCO equals VWB angle VWB? Well, it's because the exterior angle of cyclic quad, exterior angle of cyclic quad, exterior angle of cyclic quad, like so. So we have found that this angle here, alpha, equals 45 degrees. We've also found VWB, which is equal to 45 degrees. So yeah, we've answered these questions over here. Let's look at the next thing. Right, the next question. Right, in the next question, we answer part 4.4 of this question. A new circle is obtained when the given circle is reflected in the line y equals 1. See, okay, now there is x and y. Okay, so there's a line. Y equals 1. Okay. X and Y. Now, I want us to look at this carefully. Now, this new circle that is obtained when the given circle is reflected in the line y equals 1. Right, so if you reflect in the line y equals 1, what do we get? Right, so yeah, we're able to get a couple of things. And they're saying determine the coordinates of Q, the center of the new circle. Okay, so in other words, if you reflect, this is the line y equals 1. Okay, reflection of this line is going to be like this. This is going to be like this, giving a Q with the coordinates of some points. But now look, if this one is reflected, this here, it's going to be the same distance. So the distance from here to there is the same. And also, that means the x is going to be the same. X, y. So which means Q is going to have the same x. It's only the y that's going to be different. But if you go here 1 unit up, and here it is how many units here? Right, above 1, it's, okay, y is 1 here, but y is 4 there, and the difference is 3 units here. So you do another 3 units here. So if the distance is 3, it must be 3 units here. So 3 units is going to be exactly 1, and then 3. So if the distance is 3, then what does it mean? This one is already 1, so you need 2 here. So if you need 2 here, this is going to be at -2. This is going to be at -2. Okay, they're saying the coordinates of Q, and therefore the coordinates of Q are clearly -3 together with -2, like this. Okay, where's the question? So we're to determine the coordinates of Q, the center of the new circle. So the center of the new circle is the coordinates -3 and -2. Where's the question? Where's the question? Now we need to determine the equation of the new circle in the form that, okay? So this new circle has the coordinates -3, -2. And so we need to determine the equation of the new circle if this is the center. Right, remember that this new circle, it's going to have, because it's this one reflected, it's going to have radius square root of 10 units. It's going to have radius square root of 10 units, and that means we'd have x minus a squared. Y minus b squared. So that now the center is going to be this. So you put -3. Well, because the center has an x and a y, so you put -3, then you square this. And then the y minus the b is the radius, square root of 10, and you square. And this is exactly x plus 3. You square this, and this is y plus 2. And you square this. If you square that, you get exactly a 10. So obviously you have to find the equation of the new circle, and the equation of the new circle is exactly that one. So it is exactly x plus 3 plus y plus 2, which is 10. Which is 10. Right. Which is exactly 10. So we continue. So now we need to determine the equation of the new circle in that form. So the equation of okay. So we continue. Right, to determine the equation of the new circle in that form, we have found the equation of the new circle in that form. Right, where's the question? Where's a question? Right. Where's the question? Right. In the absence of a question, we move forward. And we tackle 4.4.3. The equations of the lines drawn parallel to the y-axis passing through the points of intersection of the two circles. Let's look at that one very carefully. Right, looking at 4.4.3, you want to find the equations of the lines drawn parallel to the y-axis passing through the points of intersection of the two circles. So obviously, if you reflect about the line y equals 1, there's going to be this one here. It's going to be a little bit here. And if you put a mirror along the line y equals 1, it's going to show the whole big circle there, like so. Okay. What then do we do with this information? We then continue to analyze these with match quotient. With match quotient, and we continue to solve these, but also to determine the equations of the lines parallel to the y-axis passing through the points of intersection of the two circles. So in other words, there's going to be a line here. There's a point of intersection. There's a line here like this. There's another line here like this. Okay. So there's another line here like this. There's another line here like this. Okay. So now, the question is, these equations, these are vertical lines, and each one is parallel to the y-axis. So there must be x equal to something, x equal to something. What are they? Okay. What are those lines there? What are they? What are those lines? What are they? Those lines. What are they? And how do we find the equation? So in other words, at this point, we need to think and realize that we need to find the there is a, for example, if you look very carefully here, you can see that there is a point of intersection here. Right, so there's a point of intersection there. And also, along this line, there's going to be another point of intersection there. The easiest way is just to equate the two circles. So you have x, the equation we got, which is x plus 3 all squared y plus 2, which is 10. And then we have the other one. Okay, this one is center Q. Center Q. And this one, which is x plus 3, y minus 4, 10. This circle has center P, because you can see the 3 and the 4. Okay. Now this here are the two circles whose equations we know. But now you can use any one of these circles with y equals 1. Okay, y equals 1. So you're going to use x plus 3. You square, and then y equals 1. You add 10. X plus 3 squared plus 1 plus 2 is 3. You square that, it's a 9. 10. X plus 3 squared. 10 minus 9 is a 1. So which means that if you take the square root, this is x plus 3 equals plus or minus 1. X plus 3 is 1, or x plus 3 is minus 1, which means x is minus 2, or x is minus 4. Okay. So, right. And you can use also the other equation as well. You can use also any one. We use the top equation with center Q, but we can use also the other equation with center P. Right, and then we shall get the same result. Right, so obviously now the two equations of the lines in this question here are exactly x equals minus 2, right, or x equals minus 4, like that. So we got that answer, and we've been able to solve question 4.3 that way. And we continue to solve more problems, to solve more and more problems as follows. Right, so yeah, trigonometry is okay. But I want us to sine, cosine rule. We did that last year. 11, and it's also there in matrix. So we're going to discuss it, the sine, cosine rule, when the time is right. But let us spend some time and discuss some circles a little bit here. In the diagram, MP is the diameter of a circle. Here is M and here is P. T is actually the diameter of a circle centered at O. MP cuts the chord NR at T. Q. So if MP cuts the chord NR at T, radius NO, and chords PR, MN, and MR are drawn, the angle R1 is 69 degrees. Here's the angle R1. It is actually equal to 69 degrees there. We proceed to solve this problem, but to solve this problem in a step-by-step fashion. Now, determine, giving reason, the size of the angle R2. This angle here. What is the size of that angle? What is the size of that angle? And first things first, right, I can give you some time, some chance to try that one. Right, anyone home who can try that one? What is the size of the angle R2 and why? Tando, what do you think? What is the size of the angle R2?
R2 is 21.
21 degrees. Well done. Right. So to find the size of the angle R2, we first know that this entire angle equals 90 degrees. So we say the angle MRP is actually equal to 90 degrees minus 69 degrees, which is 21 degrees. Okay, but first, let us do this. I'm going to write it a bit nicely. So we say the angle MRP, that's what I'm trying to say there. The angle MRP is equal to 90 degrees. And why is this angle equal to 90 degrees? Because it is an angle subtended by diameter. The angle MRP is obtained by diameter, so it is an angle in semicircle. Angle in semicircle. Angle in semicircle. And we're able to then say, hence, the angle R2 is 90 degrees minus 69 degrees. So that the angle R2, as it is wanted, it is actually 21 degrees. It is 21 degrees. What is the size of the angle O1? This one. Anyone who can find the size of the angle O1? So continue. Right, want to find the size of the angle O1. Let us see how we can find the size of the angle O1. Right, who knows? Anyone? People are asleep. Are people fast asleep? I'm trying to test the geometrical skills. Angle O1. What is the size of the angle O1? Anyone home? Right. What is the size of the angle O1?
Say O1 is 2 times the angle at circumference,
Yeah.
making it
Okay. Well, what do you think the size is?
138.
138 degrees. Okay, 138 degrees. Now that is a very, very interesting. So in other words, we're able to see that the angle O1, so you can see this theorem. This is the theorem. A rule, a law. Angle at center is twice the time. So angle O1 is 2 times 69. 138 degrees. 138 degrees. In this, is that angle at center is equal to 2 times angle at circumference. 2 times angle at circumference. Right, so we have that the angle 1 is 138 degrees. 108 degrees. What is the size of the angle M1? Anyone? The size of the angle M1. Who knows? M1.
21, sir.
21 degrees. Okay, well done. Why is it 21 degrees? That's Senulo. Why is it? Your answer is correct, Senulo. Yeah, it is 21 degrees. I agree with you, but why? Why is it not like 1 billion degrees, or somebody can say it is a trillion
Angles in
degrees?
the same segment, sir.
Angles in the same segment. Okay. Your angles in the same segment. With which one? With which angle? With the angle 2. Well done. Angles in the same segment. Right. Well done. I'm excited that Senator was able to get that one right. Angles in the same segment. Next question. Angles in the same segment. Okay, next. Let's find M2. Angle M2. What is the size of the angle M2? What is the size of the angle M2? Anyone? What is the size of the angle M2? Who knows? The angle M2. Let me clean the board. Let me clean this up. It has become so untidy. What is the size of the angle M2 in this diagram? The angle M2. What is the size of it? Who knows the angle M2? Right. Is it because no one knows what the angle is? Is it too difficult, too easy? We want the angle M2. So anyone home who knows the angle M2? What is the size of the angle M2? What is the size of the angle M2? No one knows. Because you can see the M2 is this angle here. Right. Tando, what do you think angle M2 is? Anyone? The angle M2. Just remove this. The angle M2.
M2.
Yes. What do you think? It's already too obvious. It's already very, very obvious. Obvious. The angle M2. The angle M.
So isn't it 21?
It's close to that, but it's different. It's close to that, but it's different. Right, it is close to that, but it's different. So, yeah, so what is it? Okay, we just need to find the size of the angle O2. We just need to find the size of the angle O2. We need to start, because if it is further given that NO is parallel to PR, NO is parallel to PR, so yeah, like this. Those are parallel. So if you have NO is parallel to PR, So this angle is equal to this. Okay, so yeah. What do you have? So what is the size of the angle O2? Okay, let's start there. Who can find the size of the angle O2?
42, sir.
It is 42 degrees. Well done. Why is it 42 degrees? I agree with you.
Sum of
Yeah,
angles of straight line.
yeah, definitely, because we've already found 01 to 138 degrees. So this one is that in the it is the angles. We just say angles on a straight line. And obviously, I mean, the best way is to say the angles must be next to each other on a straight line. And to say that they must be next to each other on a straight line, we say they're adjacent angles on a straight line. Adjacent angles on a straight line. Adjacent angles on a straight line. Okay. So we continue. Adjacent angles on a straight line. Okay, so yeah, that's O2. So O2 is 42 degrees. Then what is angle P? Then what is angle P? What is the size of the angle P? This one. Angle
Same
P.
size, sir.
Why? I agree with you, but why?
Alt angles.
Yes, these are alternate
Alternate angles.
angles. Yeah, they're alternate angles. So you have alternate angles. Why are they alternate angles? What lines are parallel to each other?
NO and PR.
Yeah, NO and PR. Well done. You see, doing so well there, Sinulo. You're doing so well. And then now, found that this one is also 42 degrees. Then what is the size of the what is the size of the angle M2 now? What is the size of the angle M2 now? M2 is equal to what? M2 is equal to what?
58, sir.
Please come again.
58.
Okay, you close, but there's something small missing. Just do your algebra. The addition did not quite go right. Just add your numbers correctly. You close to the answer.
48, sir. 48. Yeah, I can
48,
see 48.
48, 48 degrees, because you just said 58, so I was like, okay, you're too close to that. It's actually exactly 48 degrees. Right, since it is 48 degrees, what is the reason for that? The reason for that,
Interior angles of a triangle.
yes, the sum of the interior angles of a triangle, and obviously we say that the sum of angles in triangle. Sum of angles in triangle. Sum of angles in triangle. So we found the size of the angle M2, and therefore we have that the angle M2 is equal to 48 degrees. The angle M2 is equal to 48 degrees. Is equal to 48 degrees. Is equal to 48 degrees. Okay, next question. Right. Next, we want to determine the value of x. And we say that in the diagram below, A, B, C, D is a cyclic quadrilateral. So we have A, B, C, D is a cyclic quadrilateral. A, B, and D, C. A, B, and D, C are produced to meet at E. A, D, and B, C. A, D, and B, C are produced to meet at F. A, F, B is 2x. A, F, B is 2x. D, A, B. D, A, B is 3x. AED, angle AED. Right, angle AED is x. Determine, giving reasons, the value of x. I'm giving you 3 minutes to do this question. Like 1 minute, I know that you can do it quickly. What is the value of x here? What is the value of x? Who can find the value of x? What is the value of x? Quickly. Quickly. I'm giving you like a minute. Just write quickly. And then quickly find the answer. What is the value of x? Find the value of x. What is the value of x? What is the value of x? What is the value of x? Who knows? Senula, what's the answer?
Still calculating, sir.
Okay. Tando. What is the answer, Tando?
I'm not done, sir.
Okay. Are you able to see the question?
Yes, I am.
Okay, good. Please notify me as soon as you found x, because the question is saying determine, giving reasons, the value of x. Determine, giving reasons, the value of x. Determine, giving reasons, the value of x. The value of x. Determine, giving reasons, the value of x. Right. Determine, giving reasons, the value of x. Right. Exactly the value of x. Value of x. The value of x. Right, if you're done, please alert me that I am done. And then we shall check together and see what we can do. The aim is to train you and make you the best you can be. The aim is to produce top-notch science students. Top-notch science students. Top-notch science students. Top-notch science students. Okay, anyone home? This is too easy. Too easy. Very easy. Grade 10 work. Grade 10 work mixed with grade 11 work. So, yeah, grade 10 work mixed with grade 11 work. Right. So who knows? Here's the answer. Who has the answer? Who has the answer? Right. Anyone home? Anyone home? No one. Sanulo, how far? We want the value of x. We want the value of x. We want the value of x. Hey.
20.
Please come again.
20.
Well done. Congratulations. That's Sanulo, right? Congratulations.
Yes, sir.
It's exactly 20 degrees. And we're going to use the grade 10 result here. If you have A, B, C, and this is 1 and 2, then the angle C1 is A plus B. And we say exterior angle of triangle. Exterior angle of triangle. So now if you have here, you have this. So that we have the angle D1. Right, this is exterior angle of the triangle, so the angle D1 is equal to x plus 3x, which is equal to 4x. Why? This is exterior angle of triangle. Exterior angle of triangle. Next, you also now, having been done with that one, we can remove this and now focus on the other one. And you have this. So you can find now the size of the angle B1, for example. The angle B1 is the exterior angle of triangle is equal to 2x plus 3x, which is 5x. Exterior angle of triangle. So we take those angles and we put them here. And this is exactly 5x. And then this D1 is x plus 3x, which is 4x, like this. Right, so we can then find the angle D2. The angle D2 is 180 degrees minus 4x. This angle D2, this one here, is 180 degrees minus 4x. Why? These are adjacent angles on a straight line. Adjacent angles on a straight line. Adjacent angles on a straight line. Okay, in the end, then you're able to see, therefore, that the angle D2 is 180 degrees minus 4x. Okay, so yeah, you have this one and that one. And then from this, we're able to see that the angle B1 is equal to the angle D2. Why? Exterior angle of cyclic quad. Exterior angle of cyclic quad. So that the angle B1 is 5x. The angle D2 is 180 degrees minus 4x. And you bring this one across, it becomes 9x is 180 degrees, which means x is 180 degrees divided by 9. And 180 degrees divided by 9 is exactly 20 degrees. It's exactly 20 degrees. So determine the value of x. X is 20. X is exactly 20 degrees. It was awesome having a discussion with you guys. Thanks so much for joining us. We're going to be right back at 8 p.m. Okay, it was just a one session now at 4 p.m. Yeah. So thanks a lot for joining us. Very, very interesting discussion we've had.